Good morning, everyone. Today we are going to continue with chapter number 7, Object Oriented Design. In last session, we have seen the Wooch method, Cod and Jordan method, and Jacobson method and Rumbach method. In today's session, we are going to continue with the generic components of the Object Oriented Design model. Here, we are going to continue with the generic components of the Object Oriented Design model. First model is, or the first generic component of that object oriented design model is the problem domain component. So that problem domain component includes the problem domain classes that were identified during object oriented analysis. So the component or the subsystem that achieve customer requirements. This component achieve the customer requirements. Depending on the customer requirements, the design pattern knows the problem exactly. What is the problem domain or what is the problem definition exactly based on the requirements. So, however, changes might be made in order to take advantage of reusable classes that are already available, as well as changes needed to improve the performance. So, this is the problem domain component of the object oriented design model. In this, we are going to achieve the customer requirements. Depending on that customer requirements, we are going to design, or we are going to know the what is the problem domain or what is the problem exactly, the problem definition of the design. The next component is human interaction component. So this is very important component of that object oriented design model, since using this component a model interacts with human. In this uh, by using this component, the object in object oriented design model, that model interacts with the human, that is user interface or the human interaction with the system, the components or the subsystems that achieve user interface. As I said that in this component, that human is going to interact with the system, that is we are going to achieve that user interface, or that through that GUI we are going to interact with the system. Here you can see the example for this. Consider one Microsoft Excel has various cells. Here you can see the cells which we put the entries and manipulate them, like each different entry is classified into different manner. Here you can see the three cells are there: ID, name, and salary. Okay, so here this is the example of a one database, considering we are having ID, name, and salary. So here in this table you can see three columns are there for ID, name, and salary, which are according to the class design. Okay, here all of these three are attributes. Here all three are the attributes of that class. Here name, ID, and salary. And the operations, here we are going to do some operations here, like we are going to calculate the sum of this salary. Here you can see this last column or this last row is for the sum of all these four IDs. Okay, that is the operation, that is we are going to make the sum of this all the columns. Okay, so we are also using that alternative pattern in this object oriented design here. So that is the human interaction component for object oriented design model. Then third component is task management component. So in task management component, that subsystems or the components are that control and coordinate the concurrent tasks. The tasks that are going to happen at the same time, we are going to control that task in the object oriented design. That is task management. We are going to manage the task. Then next component is data management component. So here in these subsystems that store the data and retrieve the objects, we are going to manage the data in object oriented design model. That means we are going to retrieve the data from the database, or we are going to retrieve the objects. We are going to store the data. Here you can see the looping within the components. Here you can see in this diagram, looping within the components. So first we are having design classes. that having methods and attributes and associations. Then we are going to apply some designs, and we are going to refine the UML or the class diagrams based on that problem definition. Then we are going to, after analyzing, we are going to design the view, access layer and prototype here. Then based on that, we are going to test that model or that design, that user satisfaction, then usability test based on that use cases. So here you can see they all are connected to each other. This is the looping within the components, that this component is for the problem domain, then this is for human interaction, then the task management and the data management component. So next point is the system design process. A system design is the process of defining elements of the system. We are going to define the elements of a system like modules, architecture, components, and their interfaces, and the data for a system based on the specified requirements. At the initial stage, we are having requirements for the particular design. Based on the design, we are going to find the modules and then draw the architecture and components and their interfaces based on that requirements. So this design can be defined in the graphical or the textual form or the textual modeling languages. So during system design, the developer makes planned decisions with broad consequences. So the architecture is a high level plan, or we can say that the strategy for solving the application of or that problem domain. So best plan is implemented by user requirements, as well as some previous experiments are there. Based on that, we are going to implement that user requirements. So here you can see the process flow of object oriented design. Here you can see the system flow or the process flow. First, we are going to analyze the system, that is object oriented analysis. Then see the components or the generic components of object oriented design. Here task management design, then data management design, human interface design, then object design, and at last system design is there. So this is the process flow of object oriented design. So we have seen that process flow starts from the object oriented analysis and ends with the system design. So we have studied that in chapter number 6, that in object oriented analysis, that what is object oriented analysis, what are the phases in that analysis. Okay, and that system, that flow is end with system design. So to design the system, so we have to, that a previously analyzed model can be implemented. Yeah, you can see the to design the system, we have to we are working on the previously analyzed model, okay, that we are going to implement. This is the process flow of object oriented design. Then next one is partitioning the analysis model. The model we are going to analyze, we have to partition this model. Yeah, that uh, before that, in system analysis and design phase, the more focus is on what that user needs to be done, what needs to be done, or independent task is there. So developer take decision on how problem will be solved. Okay, so mainly focus is on the analysis and the design. So during that system design stage, it solves the problem like that overall structure of the system, that it solves the problem basically arises from the system analysis phase. Then a developer has to think on like overall structure of the system, then the style of that system, and the subsystem and how we can reuse that system. Okay, so here for that we have to partition. So first one is partitioning the analysis model. We have to partition, we have to decompose the particular system. Here decomposition of the proposed system into small simple subsystem based on the knowledge of the problem domain. So we have to decompose the particular system with the small or simple subsystem based on the particular problem domain, and propose the architecture of the target system based on the requirements. So here breaking up of the system into small pieces of the subsystems is the first step of system design. The first step of system design is we have to decompose the proposed system into small pieces of the subsystems. So since that major piece which further implemented is nothing but the subsystem, here you can see we are having one system here, and that particular system is going to be decomposed. Here you can see the decomposition of that particular system. These are the small pieces or the subsystems we can say. So that is nothing but the partitioning of the analysis model. Okay, here you can see the partitioning of the analysis model. Then that subsystem is a group of classes, associations, operations, events, and constraints that are interrelated and have an interface with other subsystems. So these are this subsystem can be classes, associations between their classes, then the operations, events, and the constraints that are all are interrelated to one another. So that subsystems are identified based on whatever services are provided by the subsystem. Okay. So yeah, this is all about that partitioning the analysis model here. We are going to decompose the system into subsystem. So that subsystem can be partitionally, or we can say that subsystem can be partitioned internally to help reduce the complexity. Yeah, we have seen that number of that subsystem should be kept small. Then that subsystem should have a well-defined interface. Okay. Then next one is concurrency and subsystem allocation. So in real world, objects are concurrent. Concurrent means here we can say that in real world that problem as well as that here we can say that, for example, how that objects are real world objects are concurrent here. So see the example, we work with printer, speaker, keyboard as well as many hardware objects work together for completing one task. Yeah, this is all about hardware object. Yeah, this is all about the hardware object, but this cannot follows with the all software objects. So these things are different. Hardware and software are different. So that if you say that printer, speaker, or that particular hardware objects are working together, but it is not possible in case of that software objects. So it is not always concurrent. So the reason is that one process supports many objects. One process, sorry, the reason is that one process supports many objects. It's possible in hardware, but it is not possible in the software object. So hence that single object can't be utilized at the same time. We cannot utilize that single object at the same time for the multiple processes or multiple tasks. So for that we have to identify the inherent concurrency. Identifying that inherent concurrency means here two objects are inherently concurrent if they react on the events at the same time without interacting. We can say that two objects are inherently concurrent if they are going to react on the events at the same time without interacting with another. So here you can see the example of CPU and speaker. CPU and speaker on a computer must operate concurrently. Then at a time only one object can active on control of one thread up till one object passes an event to the other object. The thread will remain in the particular state diagram and wait for upcoming event. That means the thread has to wait for that upcoming event. Okay, or that object in that particular state is there. Object is in that particular state. That object has to wait for that upcoming event. So that thread will pass to the receiver object till it gradually come back to the original object. So that means that thread breaks when an object passes and event continues with that execution. So this is all about concurrency and subsystem allocation. That means in real world objects are concurrent. We have seen one example for that we are going to work with printer, speaker, keyboard as well as many hardware objects that are work together. That means we are going to work with that objects together, like we are going to print some data, then speaker is working, then we are handling that keyboard. Okay, so but this is not all about, this is not in case of that software objects. So it is not always concurrent, like the reason behind that one process supports many objects. Then next component is the task management component. So in task management component we have seen that concurrent systems assign each concurrent subsystem to a hardware unit, either that as a general purpose processor or a specialized functional unit. So in task management component, we have to manage the task for determining the performance and the required resources, then choosing an implementation of hardware or software for subsystems. So here it allocates software subsystems to processor so as to achieve faster performance and reduce the inter-process communication. So the task management component having some steps like estimating the hardware resource requirement, then making hardware software trade-off, then allocating task to processor and determine the physical connectivity. So that estimating hardware resource requirement includes that if a single unit can give the less performance, then then only we can think about more number of units in action. If that single unit can give the less performance, then only come into that more that we can think about that multiple number of units that are into action. So in case of computer, a single CPU performance is less, then we go for use of multiple processor or hardware units, which is based for the higher performance. For higher performance we are going to work with that, or we are going to use that multiple processor hardware. So that this high performance processor depends on like volume of computation, then speed, then output of that machine, then that processing time, that is estimating the hardware resource requirement. Then next one is making hardware and software trade-off. So in object oriented design, the duty of that system designer is thinking about which hardware or which software is suitable for the implementation. So making hardware and software trade-off means in object-oriented design, that system designer has to think about which hardware and which software is going to support for that particular implementation. So there are some major factors that system designer has to think at the time of choosing that subsystem in the hardware. So first one is cost and performance. Based on the cost of that hardware and the performance of that hardware, we are going to choose that subsystem for that subsystem in the hardware. And next one is allocating task to processor. So allocating task to processor means, yeah, there are various different reasons by which that system design must allocate tasks for the various software systems to processors. Like certain tasks are required at specific physical location. So to control that hardware or to permit independent operations, we have to allocate the task to processor. Then the response time or the data flow rate exceeds the available communication bandwidth between a task and the piece of hardware. So here to support that task, several processor must use, since that communication rates are too great for a single processor. Then next one is determine physical connectivity. So in that we have to choose the topology of repeated units. Then we have to choose the form of the connection channels and the communication protocol. So this is all about that task management component. For that, we have to estimate the hardware resource requirement. Then we have to make that hardware software trade-off, and based we have to select the hardware based on the cost and performance. Then we have to allocate the task to processor. Then we have to determine the physical connectivity between that hardwares. Then next one is the data management components. So there are various ways to store the data in the separate. We can store the data in separate form separately or in the combination. So there are several ways like data structures, files and databases. So these are like a task trade-off. Then task task trade-off, same factors like cost, access time we have seen in the task management. Cost, access time, capacity and reliability, these are the trade-off to be considered in case of data management. In case of task management, we are considering the hardware software trade-off, like we are going to consider the factors cost and performance. For data management, we are going to consider the cost, access time, then the capacity and the reliability. Then that files are like cheap, simple and permanent. Sorry, that file operations are low level. Applications may vary for different processor. Then that portability are sometimes not in use. So these are the file operations for the data management component. Then the database managed by the DBMS. That database is managed by the DBMS based on that your cost comparatively high with files. Then that better performance than files, always portable. Then complex interface is there. Then next component is the resource management component. In this, the system designer identifies the global resources. Global resources like physical units. Then, yeah, physical units can be processor, tape drivers, or communication satellites. So that physical resources can control itself by establishing a protocol for obtaining the access of that physical units. Then that resources or that system designer identifies resources like a space may be disk space or workstation screens. Then the logical entities, databases. Your logical entities are like object id, file names, class names. So in case of logical entities, there is a risk in conflicting access in a shared environment. If that what we can say that that units are share, then that there may be a risk of conflicting access. That if that one unit is shared by another, what we can say, that unit is allocated to that another task, so there may be a conflicting while we are going to share that particular unit. Then in this the software engineer identifies the mechanism for granting the data access to the resources. So yeah, resource management component, we are going to manage the resources. That resources may be physical units like processor, tape drivers, and communication satellites. And there may be space, then the logical entities. Okay. Then next part is inter-subsystem communication. So in this, that interactive interface means the communication protocol between the one subsystem with another subsystem. There are some major issues of that inter-subsystem communication like proper syntax, output format, flow control, then the user interface, performance and error handling. So in inter-subsystem communication, that interactive interface is there for that communication between that subsystem. Then the last topic from the chapter number 7, that is object design process. So there may be a question in your exam. Give this object design process steps, or that there may be questions like what are the steps for the object design process. Okay, so that object design process means, yeah, a protocol description and implementation description. So a protocol description produces an interface, or we can say that communication among the objects by sending messages between them and defining the related operations. Protocol description means it produces an interface between that objects by sending messages between that objects or by defining the related operations between that objects. Then the implementation description. It shows implementation details for each operation that are implied by the message that is sent to an object. That messages are sent to that particular objects. So that implementation description shows the implementation details of that particular object. Then, so this implementation details includes that information about objects, private properties and methods. Then the data structure, internal data structures of that object. Internal data structures means attributes of that object. Then the internal procedural details. Internal procedural details means that operations of that object. So that implementation details include the object's private properties and methods and attributes and operations. That means data structure and the procedures. Then here see the different steps of object design process. So that first step is we have to develop a problem statement. Then we have to identify the objects and classes for that particular problem domain. Based on that requirements, we have to identify the objects and classes. Then we have to filter out that required classes, which classes are necessary, which are extra classes are there. We have to filter out from that we have to filter out that required classes from based on that identify from that identified objects and classes based on that requirements. Based on that requirements, we are going to form a problem statement. Then we have to identify that objects and classes, and in third step we have to filter out that required classes. And in the fourth step, we have to identify the association, attributes, and links between that objects and classes. Then in next step, we have to prepare the data dictionary. Data dictionary means we have to form the database, or we have to form the data tables for that particular design. Based on the classes, we have to form the tables considering the attributes like or the parameters based on the database or that attributes. Then we have to discard the unnecessary associations and attributes. Then we have to apply inheritance if it is necessary, or if it is possible we have to apply that inheritance. Then we have to check the accessibility for that possible queries. Accessibility means how we can, which attributes are accessible to that external entity, which attributes are accessible to internal entity or external entity, for that in case of that uh, what we can say, if we are going to give some constraint for that particular table. Then iterate and refine the model. And at the last step is group classes into modules. We have to group that classes into modules. That means if considering that student one module, then there are several, or if we are going to consider college one as one module, that college considers multiple classes are there. We have to group that classes into models or the modules. Okay, so these are the 10 steps of object design process. Okay, so in this way, we have finished with the chapter number 7. So that's it for today's session. Thank you.